Statistical Process Control, or SPC, is a statistical method used to monitor and improve the performance of a process. Variations in a process cause inconsistencies that affect the performance of the process. SPC uses a set of tools to detect the variations in a process so that necessary corrective actions can be adopted to reduce them. A control chart, also known as a Shewhart chart, named after its creator Walter A. Shewhart, is one of the most significant tools used in SPC to monitor a process. A control chart is a graphical representation of data representing the process output over time. The control chart can analyze different types of data, such as variable data and attribute data. Variable data is numerical value that can be measured on a continuous scale, such as length, weight, temperature, and time. Attribute data is data that can be classified into discrete categories or attributes, such as pass or fail results and yes or no responses. Typically, a control chart consists of the following components: a vertical axis, which represents the characteristic being monitored, a horizontal axis, which represents the sample number or time, a center line, or CL, which represents the average or target level of the performance of the process, and the upper and lower lines, known as the upper control limit, or UCL, and the lower control limit, or LCL, which represent the acceptable range of performance of the process. The data points plotted on a control chart are typically connected by lines to reveal the pattern of performance of the process. When the process is stable, all data points will fall within the two control limits, typically in a random pattern. If any data points fall outside of the control limits, this may indicate that the process is out of control and requires inspection and correction. When all the data points fall within the control limits yet exhibit a pattern that is not random, this might also suggest a potential source of variation.